In this lecture of signals and systems, we will solve some problems on Laplace transform and draw their ROCs. Consider the first signal u of t. So for a unit step signal, we need to find Laplace transform and draw its ROC. For the solution, write down the formula of Laplace transform. So Laplace transform of x of t is equal to integral minus infinity to infinity x of t e raised to minus st dt. Here the signal is u of t. So Laplace transform of u of t is equal to integral minus infinity to infinity u of t e raised to minus st dt. We know that unit step signal is having a value equal to 1 from 0 to infinity. So the equation is modified as integral 0 to infinity u of t is equal to 1 e raised to minus st dt. Solving this integral, we have e raised to minus st divided by minus s over a range 0 to infinity. So substituting the values, we know that e raised to infinity is equal to 0 minus e raised to 0 is equal to 1. So we have minus 1 divided by s. So the final answer is 1 divided by s. In order to get the poles, we know that the denominator is required to be equated to 0. So s is equal to 0. 0 is the pole. So the ROC will be RE of s greater than 0. Since u of t is a right-sided signal, so the ROC will be also right-sided. So when you are drawing a region of convergence, mark the pole 0 and draw the ROC towards right. So the shaded region indicates the ROC in the S-plane. Calculate the Laplace transform of e raised to minus at u of t and determine the ROC. For any signal, Laplace transform of x of t is equal to integral minus infinity to infinity x of t e raised to minus st dt. Laplace transform of x of t can be always represented as x of s. Now, instead of x of t, we need to take the given signal e raised to minus at u of t. So, Laplace transform of e raised to minus at u of t is equal to integral minus infinity to infinity e raised to minus at u of t e raised to minus st dt. Now, we know that u of t is valid only from 0 to infinity. U of t has a value equal to 1 from 0 to infinity. And from 0 to minus infinity, u of t is equal to 0. So in the integral varying from minus infinity to 0, if we take u of t is equal to 0, we know that if this signal is multiplied to any other signal, the answer will be equal to 0. So we don't consider the integral part ranging from minus infinity to 0. Then the integral varying from 0 to infinity, we know that u of t is equal to 1. So we have a signal integral 0 to infinity e raised to minus at u of t is equal to 1 and e raised to minus st dt. Combining this exponential term, we have integral minus 0 to infinity e raised to minus s plus a into t dt. Solving the integral further, we have e raised to minus s plus a into t divided by minus s plus a. The limits are 0 and infinity. Then substitute the value of infinity at t's place. We have e raised to infinity, that is equal to 0, minus substituting t is equal to 0, we have e raised to 0, that is equal to 1. So we have minus 1 divided by s plus a. So the final answer we get of the Laplace transform e raised to minus at u of t is 1 divided by s plus a. Now, how to get the ROC? For that, first we need to get the pole. So that is found by equating the denominator equal to 0. So we have s plus a is equal to 0. So we get s is equal to minus a. Now, whether real of s is greater than minus a or less than minus a, that is been decided based on the given signal. We have already seen the properties of ROC, that is, if the signal is a right-sided signal, then the ROC is also towards right side. And if the given signal is a left-sided signal, then the ROC will be left-sided signal. So here you can just see in the rough work, e raised to minus at is a decaying exponential signal. U of t is a signal which is varying from 0 to infinity. When we multiply these two signals, the output obtained will be again a exponential signal which is varying from 0 to infinity. So we know that this signal is a right-sided signal. That's why real of s is greater than minus a. So when we draw ROC, we draw a pole on the sigma axis, that is minus a. Draw a straight line passing through it which is parallel to j omega, and then draw a shaded region towards right side. So this is the Laplace transform and the ROC of e raised to minus at u of t. The third signal is minus e raised to minus at u of minus t. Again we need to find the Laplace transform and the ROC of the signal. First, writing the formula of the Laplace transform, we have integral minus infinity to infinity x of t e raised to minus st dt. So the Laplace transform of minus e raised to minus at u of minus t is equal to integral minus infinity to 0 minus e raised to minus at u of minus t e raised to minus st dt. Now in the rough work, if I try to draw the given signal, we have e raised to minus at, that is a decaying exponential signal. U of minus t is a signal which is varying from 0 to minus infinity. When these two signals are multiplied, we are getting the upper part of the exponential signal. And since the whole signal is multiplied with a negative sign, the signal is getting inverted. So we know that the given signal is a left-sided signal. So solving the Laplace transform, we have integral minus infinity to infinity minus e raised to minus at u of minus t e raised to minus st dt. Since u of minus t is varying from 0 to minus infinity, we have integral limits changed to minus infinity to 0 e raised to minus s plus a into t dt. So taking the minus sign out, we have minus integral minus infinity to 0 e raised to minus s plus a into t dt. Now we know that if we want to interchange the limits of the integral, we can add one more negative sign to it. So we have minus minus, so that becomes plus integral 0 to minus infinity e raised to minus s plus a into t dt. Now what we are doing, instead of t, we will take the whole expression for t is equal to minus t. So the integral is changed to 0 to infinity e raised to t is substituted as minus t. So we have e raised to s plus a into t, dt will be changed to minus dt. So we have minus integral 0 to infinity e raised to s plus a into t dt. Solving the integral, we have e raised to s plus a into t divided by s plus a. The whole expression is having a negative sign and the limits are varying from 0 to infinity. This is equal to, if we substitute t equal to infinity, we have e raised to infinity, that is equal to 0, plus minus e raised to, if we substitute t is equal to 0, that is e raised to 0 is equal to 1. So we have minus minus plus 1 divided by s plus a. So the Laplace transform is 1 divided by s plus a. Now, in order to get the ROC, we need to equate the denominator to 0. So we have a pole at s is equal to minus a. Since the given expression is a left-sided signal as it involves u of minus t term, we have region of convergence as real of s less than minus a. So for a ROC, we draw a pole on the s-plane at minus a, draw a straight line passing through it and draw the shaded region towards left side. For more problems on Laplace transform, please refer the next video.